Everyone, today we're going to talk a little bit more about ionic bonding. So, we've got three main goals for today. We want to understand how cations, remember cations are positive, and anions, which are negative ions, can come together to form an ionic bond and create a chemical compound. We also want to understand how to figure out what the formula of a chemical compound made from any two ions would be, and we want to understand how we would name those chemical compounds. So first off, a little bit of review. Atoms form ions because forming ions is a way of making yourself more stable. So to become stable, what they're trying to do is empty out or fill that outermost electron shell. They want to end up with 8 valence electrons in most cases. So here, for example, with sodium, sodium has 1 valence electron. Sodium has 1 valence electron, but if it loses that electron, then we'll only have 2 shells, and that outermost shell will be full. That makes the sodium ion much more stable than a sodium atom. Remember, the first shell can only hold up to 2 electrons, so you see 2 electrons in that innermost shell. The second shell can hold up to 8. Third shell can also hold up to 8. And you'll notice that we tend to put these electrons into pairs so that they're nice and easy to see and tell how many need to be gained or lost. We also have already talked about chemical formulas. So just a reminder that when we are talking about chemical formulas, the charge of an ion is always written as a superscript. So here, for example, sodium forms an ion with a charge of +1. Remember that if the charge is +1 or -1, you're allowed to just write plus or minus. But if it's +2 or +3 or -2 or -3, then you have to say how positive or how negative it is. Remember that positive ions are called cations. So here, both magnesium and sodium are cations, while negative ions are called anions. So here, chlorine is an anion with a charge of -1, and oxygen is an anion with a charge of -2. Now, when atoms come together to form ions, the best way to imagine this is to think of ions as tiny magnets. Opposite charges are attracted to one another. So if you've got an ion with a positive charge, it's going to be pulled towards things that have a negative charge. So while an ion is more stable than an atom, it's not completely stable yet. In order to become completely stable, what it really needs is to have no charge at all. So a compound as a whole will be neutral, which means it'll have a cation, something positive, and an anion, something negative, and that positive and that negative are going to add together to create no charge. Basically, the charge from the cation and the charge from the anion is going to cancel itself out. So in order to have a truly stable chemical compound, you're going to have something where all of the outermost electron shells will be full for every single atom or ion that's part of it, and there's not going to be a charge. So across the entire compound, there will be the same number of protons as there are electrons. So in order to figure out exactly what kind of formula you would have for an ionic compound, you have to bear in mind we're trying to create something neutral. So same number of positive and negative charges. Now let's take a moment and see what exactly I mean by. All right, so here we have some examples of some common cations and some anions. So sodium is a cation with a charge of +1. Fluorine is an anion with a charge of -1. Magnesium is a cation with a charge of +2. Oxygen is an anion with a charge of -2. Aluminum is a cation with a charge of +3. And nitrogen is, or nitride, if it's the ion, is an anion with a charge of -3. Now, what we can do if we're trying to create a stable chemical compound is we need to match these up. You'll have one cation and one anion, and importantly, the charges have to balance each other out. So some of these are really easy to make. If you want to make something like, say, sodium fluoride, you could just take one sodium and one fluorine, because sodium has a charge of +1, fluorine has a charge of -1. So NaF, that's a stable chemical compound. One sodium, one fluoride, the charges balance out. +1, -1, easy peasy. Likewise, you could do something like magnesium oxide with 1 magnesium, which has a charge of +2, and 1 oxygen, which has a charge of -2. And you can see +2, -2, those two charges are going to cancel each other out as well. I could do the same thing with aluminum nitride. Aluminum forms an ion with a charge of +3. Nitride is an ion of nitrogen with a charge of -3. +3, -3, those things cancel out. So all of these would be stable chemical compounds. Now where it gets tricky is if you have a cation and an anion with different charges. So let's say I want to make an ionic compound out of sodium, which has a charge of +1, and oxygen, which has a charge of -2. What I would need to do there is think about how many positive charges I have total and how many negative charges I have total. So if sodium, each individual sodium has a charge of +1, and each individual oxygen has a charge of -2, I'm going to need 2 sodiums to balance out 1 oxygen. That means that the actual chemical formula for sodium oxide would be Na2O, with 2 sodiums for every 1 oxygen. That way I have the same number of charges total. Now let's say I wanted to make something out of magnesium, which has a charge of +2, and fluoride, which has a charge of -1. Same sort of deal. Magnesium is +2, okay? Fluoride, however, is only -1, so I'm going to need 2 fluoride ions to balance out the 1 magnesium. So my chemical formula for magnesium fluoride is MgF2. 2 fluorines, 1 magnesium. Where this can be a little bit trickier is if the charges are a little bit more complex, like if you've got something that's +2 and something that's +3. So let's try a few like that. Let's say I want to have magnesium nitride. So that means I've got a cation with a charge of +2, so Mg+2, and an anion with a charge of -3. So now I need to think, well, how many magnesiums are going to balance out how many nitrogens? The trick here is just take this number here and sort of move it down to the corner for the other one. So I will actually have 3 magnesiums. Then I can take this number right here and move it down here. So I will have 2 nitrogens. And the important thing to notice here is if I have 3 magnesiums, each of which is +2, then I've got +2, +2, +2, a total of 6 positive charges. And if I've got 2 nitrides, each of which is -3, I have -3, -3, that's 6 negative charges. So that balances each other out. So magnesium nitride is made out of 3 magnesiums and 2 nitrogens. Let's say I wanted to do, let's go with aluminum oxides. This is when aluminum rusts. So aluminum oxide, each aluminum has 3 positive charges. Each oxygen has 2 negative charges. So I'm going to need 2 aluminums to balance out every 3 oxygens. 3 times 2 is 6 positive charges. -2 times 3 is 6 negative charges. So again, this creates a balanced, neutral chemical compound. All right, so the last thing I want to talk about with y'all is how we're going to name these. So when you're giving the name of an ionic compound, all you do is you name the cation and follow it up with the name of the anion. You always give the cation first, and you always give the anion last. That's true both in the name and in the formulas. So you'll notice in all of these formulas over here, the cation is coming first. Now, naming the cations is really easy. Typically, it's the same as the name of the element. So the sodium cation is just called sodium. The magnesium cation is just called magnesium. The aluminum cation is just called aluminum. Naming the anions is only a tiny bit harder. Most anions have names that end in INE. So for example, fluorine, chlorine, etc. All you do to change that from an atom name into an anion name is you take off that INE or whatever the ending to the element name is, and you replace it with IDE. So you have chlorine atoms and chloride anions. You have oxygen atoms and oxide anions. You have nitrogen atoms and nitride anions. And this works across the periodic table. Fluorine becomes fluoride. You can pick basically any element that you want, follow this exact same pattern. Sulfur becomes sulfide. Oxygen is oxide. And this will work across the board for you. So let's take a moment and review. We talked about how cations and anions come together to form an ionic bond, and that you can figure out the formula of an ionic compound by sort of balancing the charges, figuring out how many of this thing and how many of that thing will you need in order to have the compound as a whole be neutrally charged. And we talked about the naming conventions of ionic compounds. So the name of the cation followed by the name of the anion.